All right, good morning, y'all. Today we have a set of worksheets to complete while I'm out. This one right here, higher degree number 4, is going to have 3 pages to it. The first 2 are taking a polynomial function, it's going to be a cubic function, and using a method to find the intercepts. So you'll notice that these ones actually switch between. We've got some that say grouping and factoring. We've got some that say synthetic division and factoring. So trying out both methods to kind of see how we feel about each. Let's do one together so that we can just kind of see what the worksheet is asking. It's going to be very similar to the homework. If we look at this first one, we see the first question is the degree. What is the degree? It is 3. And 3 is odd. That tells us some important stuff about the end behavior. Leading coefficient, we're always looking on this highest degree term, and our leading coefficient is -1. So we have odd and negative, which tells me the ends are going to point in different directions, and the one going to the right towards positive infinity is actually going to be going down. So that means that there's some sort of stuff going on in the middle, and the other end is like that. Using that notation that we've talked about, as x goes to positive infinity, y goes to negative infinity, and we can see that up on that kind of brief sketch we did. Same thing as x goes to negative infinity, y goes to positive infinity. Just like if we go backwards on the graph, as x is going towards negative infinity, that y is increasing. Our max number of turns is always going to be 1 less than the highest power, 1 less than the degree of the function. So it's going to be 3 minus 1, so we're going to have 2 turns maximum. And our y-intercept is always the value right at the end. When x is 0, all of these other terms are going to go away. We're just going to be left with 0, 12. So we already know quite a bit about this. Let's see if we can do maybe we'll go by 2s on this to fit on 12. So go right there. So there's our y-intercept. Now this one's asking us to use grouping and factoring. So we're going to group and factor this one. We're going to look at our first group as negative x cubed minus 3x squared. We're going to look at our second group as 4x plus 12. And in each group, we're going to look and see if there's any sort of greatest common factor we can pull out. In this first one, just kind of by the nature of our cubic function, we're always going to have x squared. And in fact, here I've got a negative x cubed, so I might even want to take a negative out with me. That leaves me with a positive x there. And if I took the negative out, that means that I've got a positive 3 there. Looking at my second group, 4 stands out to me as a common factor. If I take 4 out, I've got x plus 3 left. This is a great sign because we wanted to see the same group left behind in both of them, x plus 3 and x plus 3. That tells me that I can take that group, write it out front, x plus 3, and then make another group out of what was left behind. Oops. Erase that. Make another group out of what was left behind. We have negative x squared plus 4. Now at this point, this might seem a little weird to factor, but I think you'll see we could probably factor out a negative. So I'm just going to take this negative out. I'm going to bring a negative, or even we can think of it as a -1 if that's helpful. I'm going to factor that out to the front. And if I took a negative out of this, I would have x squared. If I took a negative out of this 4, I'd have -4. Now we should be able to see, okay, this looks like our square so we can think about what multiplies to -4 and adds to 0, +2, and -2. And there we go. If we think about our zeros, we've got x equals -3, x equals -2, and x equals +2. We could throw those on here. let's say -3, -2, and +2. We also know that from this point, we're going to be going down. From this point, we were coming down. We kind of know that these are our end behaviors. And from there, we kind of do our best to connect what's here. Now, it's a little rough, and that's how it's going to be. We would use a graphing calculator to get an exact graph, but this lets us kind of see a visual of what's going on. That is the first task. If you want to pause and work on 1 through 6, that would be fantastic. And come back here for the third page. Again, work on 1 through 6. Don't worry about 7 and 8. Try it out if you want, but you're going to notice the factoring at the end is a little bit more challenging. And come back here. Okay, we're going to look at one example on this back page of kind of each of the questions we're looking at. Number 9 is basically asking us to get that information off of here, but we're not going to graph it. You'll notice that these ones are not cubics, so they become a little bit more challenging to get our intercepts for. But what we are interested in being able to do is to get an idea of what this is going to look like. So 8x to the 11th power. 11 is our degree, and that is odd, which tells me something important. Leading coefficient is 8. That's a positive. So we have a positive leading coefficient and an odd degree. It's going to look something like that. Because it's odd, they're going to point in different directions. Because it's positive, the one as x goes to infinity is going to also go to infinity. So it's going to be increasing on that side. We can write that in the notation of as x goes to infinity, y goes to infinity. And then on this other end, as we decrease in x, as x goes towards negative infinity, y is also going towards negative infinity. Basically, as the x is decreasing, so is the y. Our max number of turns is always 1 less than the degree. So 11 minus 1 would be 10. And our y-axis intercept is always the constant at the end, because again, as x is 0, all of these other x terms are going to go away. They're going to go to 0, and we're just left with -12. So we're going to have 0, -12. Okay. You can finish off that column, and then let's take a look at this other column. So if you want to pause and finish off this column and come back, that would be a good way to do it. Okay, looking at this final column, 14 and on, we want to be able to look at a graph and start to think about what the function might look like. So as we look at this graph, the first question is the degree odd or even? Well, I see the ends. I see these ends going in different directions. That tells me that it's actually going to be odd. We either write odd here or just circle odd there. Doesn't really matter. Now, as x is going to infinity, as x is increasing, y is also increasing. So we know that the leading coefficient is going to be positive. How many turns do we have here? Let's see. 1, 2, 3, 4. So we have 4 turns, so that means it has to be at least 5th degree. Our y-axis intercept appears to be right there at 0. So I'm going to say that that's at 0, 0. And then we might look for local minimums and maximums. These are going to be as close as you can get to a guess. These are not going to be exact, but local mins are basically anywhere where we see a dip towards the bottom. So if we're looking right here, we might say, oh, I don't know, negative 0.75 maybe, and negative 1/2, or negative 0.5, that looks like one. Maybe another one like right there. I'm going to do these in red so you can see which ones I'm looking at. Here's the second one. Maybe positive 1 and negative 2. And then let's do maybe black for the other ones. So we're looking for the local maximums. That's these top points. That's going to be -2 and maybe a little more than 4.25 maybe. And then we have 0, 0. Looks like the other one. Awesome, that's it. You can finish this off. Thank you for your hard work today. If you didn't finish this, this is all homework. You should have 75 minutes in class today to work on this, which is a lot of time. But if you didn't quite get to it, that's okay. Do finish it up for homework and turn it in on Thursday. Awesome. Thank you all.